Today, let's look at state of matter. So as we know that there are three states of matter. So what are the three states of matter?
Solid, liquid, and gas.
Yes, very good. So these are the three states of matter: solid, liquid, and gas. Now, let's make a comparison and see the characteristic of these three states of matter. So for solid, the molecules in solid are in a fixed position as shown in this diagram. This is because the molecules has not enough thermal energy to overcome the intermolecular interactions exist between the molecules, right? So where the intermolecular forces are very strong in solid. So therefore, the molecules in solid vibrate about its equilibrium position only. And as a result, the solid, right? Solid has a definite shape. So solid has a definite shape and also definite volume. And compared with liquid, the molecules in liquid have enough energy to partially overcome the intermolecular interaction exist between the molecules. And these molecules in solid can move freely, and the molecules are still in close contact. Therefore, in liquid has a definite volume, right? But the shape is indefinite because the shape will follow the shape of a container. Okay, this is solid. And let's look at the gas. So in gas, the molecule in gas have enough energy to completely overcome the intermolecular interaction between the molecule, and therefore the intermolecular forces exist between the molecules in gas are very weak, and because of this, the molecules can move freely and randomly in space, right? And therefore, the gas has no definite shape, or we say that the gas has indefinite shape and also has no definite volume, or it has an indefinite volume. The fourth state of matter is called as plasma. Okay, this is a diagram show the plasma. So plasma comprising of charged particles. Plasma can be found naturally in stars and in space. So how we generate the plasma? So plasma can be generated by heating a gas until the electron becomes detached from the parent molecules, right? So this is plasma.
Density, we use a symbol of rho, is defined as mass per unit volume. Okay, and the unit for density is kilogram per meter cube. So another term that we are going to study today is called as pressure. So pressure is force per unit area. For example, I have a cylinder, and I'd like to know that what is the pressure exerted on this surface if I apply a force of F on top of this surface. So the pressure exerted on the surface is equal to force they applied to the surface divided by the cross-section area at the surface. That is how you get the pressure. SI unit for pressure is Pascal. As you know that all the objects are deformable. So what is the meaning of deformable? Means it's able to change the shape or size when you apply the force to it. Okay, for example, a rubber band. When you apply the force to the rubber band, so it will expand. The rubber band will deform, change the shape. So if the force you apply is not exceeds the maximum limits or the yield strength of the rubber band, so when you remove the force, the object will tend to going back to the original shape. This object shows the elastic behavior. Elastic behavior means it's able to back original shape or original length after the force has been removed. So today we'll focus on this. So how do we know that whether I have applied the maximum force? Then you have to refer to one curve, call it as stress strain curve. So before we look at the curve, I'd like to introduce to you what is the meaning of this elastic modulus. So basically, the elastic modulus, we have a few elastic modulus: Young modulus, shear modulus, and Bach modulus. Okay, so elastic modulus, you can either refer to Young modulus or shear modulus or Bach modulus. But we are just cover the first one, Young modulus, and therefore most of the time when we talk about elastic modulus means we are referring to Young modulus. So the definition of elastic modulus is actually a proportional constant between the stress and strain. Elastic modulus is defined as the ratio of stress to strain. What is stress? Stress is actually something like pressure. Pressure is defined as force per unit area. This is stress. Strain is defined as the ratio of change in length to the original length. So strain is unitless. Unit for stress is same as a unit for pressure, which is Newton per meter square. Therefore, the SI unit for elastic modulus is also equal to Newton per meter square. So basically, the value of this elastic modulus will show you the stiffness of the material. If let's say I have a large value of large elastic modulus, what does it mean? Large elastic modulus indicate that the object is very stiff. Very stiff means very difficult to deform. Okay, for example, you compare diamond, okay, and rubber, right? Diamond actually is the material which is very hard. So diamond has a high value of high value of elastic modulus. So let's say I put it as Y. Y stands for Young modulus. However, rubber has a low value of Young modulus. So high value of elastic modulus indicate that the object is very difficult to deform, the object is very strong, and the object is very stiff. Okay, and therefore Young's modulus, if you want to define the Young modulus to be more accurate, we should call it as tensile stress to tensile strain, or just simply as the ratio of stress to strain. Okay, so it's also acceptable, but more accurate we call it as tensile stress to tensile strain. That is Young modulus. So the formula is still the same, F over A, which is the stress, to the strain, which is delta L over L naught, and the SI unit is still Newton per meter square. And that there's one important curve, call it as stress strain curve. According to this curve, actually we have two different regions. So the first region is follow Hooke's law. Stress here is referred to force per unit area. Strain here is a ratio of delta L to L naught. Stress is 0 means you don't apply any external force to the object, then there is no extension of the object. How to get the extension? Very simple. Okay, let's say if I refer to this object above, if the original length of the object is L naught, okay, then perhaps now I apply the force to the object, so the object will be extended. So this is the force that you apply, direction of the force. All will be in one dimension, and here is called it as delta L. That's how we get the value of delta L. So when the force applied is 0, there is no force applied, so the strain means delta L is also equal to 0. So that's why it always starts from the origin. Until a point, we call it as elastic limit. Okay, this limit means the maximum stress they can apply to the object, so that the object is still located at the region of elastic region. Okay, here is elastic region. Elastic region means the object is able to back to original shape after the external force. This force, it could be an external force or load. You add some masses to the object that has been removed. Okay, that is called it as elastic region. So up to this point. So slightly beyond the point, actually you have a few points slightly beyond the point. You can refer to your lecture slide. So elastic limit means point E here. There is an elastic limit. So just nearby the limit, we have the proportional limit. Proportional limit is from O to point P, which follow Hooke's law. It is actually a straight line. So elastic limit is the limit that the material is able to return to the original shape when the force has been removed. So after this region, we call it as plastic region. Okay, so plastic region means it is a region where the object unable back to the original shape and the object is permanently deformed. So you can see a few points here. So one of the important point is called as ultimate strength. So ultimate strength means it's the maximum force that you can apply without breaking the object.